This video lecture is for the topic Adversarial Search from the first unit, Problem Solving, for the subject Artificial Intelligence and Machine Learning. Adversarial search is a search where we examine the problem which arises when we try to plan ahead of the world and other agents are planning against us. In search strategies, they are only associated with a single agent that aims to find the solution, which often expressed in the form of sequence of action. But there might be some situations where more than one agent is searching for the solution in the same search space. This situation will happen in game playing. The environment which more than one agent is termed as multi-agent environment, in which each agent is an opponent of other agent and playing against each other. Each agent needs to consider the action of other agent and effect of that action on their performance. So, searches in which two or more players with the conflicting goals are trying to explore the same search space for the solution are called adversarial searches, often known as games. Games are modeled as search problem and heuristic evaluation function, and these are the two main factors which help to model and solve games in AI. There are two types of games can be differentiated with the following features: perfect information, imperfect information, deterministic and chance moves. There are some example games are there. For example, chess is a deterministic game with perfect information. Bridge game is chance moves with imperfect information. Perfect information is a game with the perfect information is that in which agents can look into the complete board. Agents have all the information about the game and they can see each other moves also. Examples are chess, checkers. Imperfect information, the agent do not have all the information about the game and not aware with what is going on. Such type of games are called the game with imperfect information, such as tic-tac-toe, battleship, blind bridge, etc. Deterministic games are those games which follow a strict patterns and set of rules for the games, and there is no randomness associated with them. Example: check, checkers, go, tic-tac-toe. Non-deterministic games are those games which have various unpredictable events and has a factor of chance or luck. This factor of chance or luck is introduced either dice or cards. These are random and each action response is not fixed. Such games are called as stochastic games. For example, backgammon, monopoly, poker, etc. Formalization of a problem. A game can be defined as a type of search in AI which can be formalized of the following elements. Initial state. It specifies how the game is set up at the start. Players. It specifies which player has moved in the state space. Action. It returns set of legal moves in the state space. Result. It is a transition model which specifies the result of the moves in a search space. Terminal test. It is true if the game is over, else if it is false at any case, the state where the game ends is called terminal states. Utility. A utility function gives the final numeric value for a game and ends in terminal states for a player. If it is called payoff function. It is also called payoff function. For chess, the outcomes are a win, loss or draw, and its payoff values are +1, 0, off. And for tic-tac-toe, utility values are +1, -1 and 0. Game tree. It is a tree where nodes of the tree are game states and edges of the tree are the player moves by players. Game tree involves initial state, action functions and result function. Example, we are going to see the game tree for the tic-tac-toe. There are two players, max and min. Players have an alternate turn and start with max. Max maximizes the result of the game tree, min minimizes the result. So this is the search tree we can draw for the tic-tac-toe game. Initial state. Initial state is shown as the root node. From the root node, there may be multiple possible moves from the starting position that will be listed out as the successor node of the starting node. So in this way, each node, the successor of each node will be the next possible moves that can be do on that particular state. In this way, each node will have multiple successors. So in this way, we can explore the tree until the final state. Final state is win or lose or draw. So all the successor will represent all possible options of next move. Possible moves can be performed by the players. From the initial state, the max has 9 possible moves and first he can start. Max plays X and Min plays O. And both player plays alternatively until we reach a leaf node where one player has 3 in a row or all squares are filled. Both players will compute each node minimax and minimax value, which is the best achievable utility against an optimal adversary. Suppose both players are well aware of the tic-tac-toe and playing the best play. Each player is doing his best to prevent another one from winning. Min is acting against max in the game. So the game tree, we have a layer of max, a layer of min, and each layer is called ply. Max plays X, then min puts 0 to prevent max from winning, and this game continues until the terminal node. Hence, adversarial search for the minimax procedure is, it aims to find the optimal strategy for max to win the game. It follows the approach of depth first search. In the game tree, optimal leaf node would appear at any depth of the tree. Propagate the minimax values up to the tree until the terminal node discovered. In the given game tree, the optimal strategy can be determined from the minimax value of the each node, which can be written as minimax of n. Max prefer to move to a state of maximum value and min prefer to move to the state of minimum value. Then there is a formula, utility of S. There is the formula showing the returning the values if player is equal to max, if player is equal to min. That's all about the topic. Thank you.